Hello, everyone. Welcome to ES331. So today let's start with chapter 1, and which is about the introductions of stress. And please bear with me. I have a tablet in front of me, so if I sometimes uh, cannot see the video, that means I'm working on my tablet. Okay, so let's move on. Um, the chapters have four learning goals. And the first one is the free body diagram. And I'm going to use one simple example to give a very quick review. And you should have seen this one in your statics. And then we move on to the definitions of the stress and types, unit, and directions. Follow up with a few examples to show how to analyze the stress. The last sections in chapter 1 is about learning the factors of safety. In each of those goals, I will make one short video clips. In the way you won't be bounded to long videos. Okay, so we move on to the next one, a review of the free body diagrams, and using this simple example here. So basically, this bar and this bar are elastic, which means they're going to deform under deformations. So the first task we want to find out is what, due to this given loading 30 kilonewtons applied to here downward, what is the reactions in this bar and what is reactions in this bar. Okay, so we pick up this free bar diagram of this portion of the interest. So if you want to draw, you can draw like this. Sorry, my working on my tablet. Um, so that is these portions. Okay. So the loading applied is to here 30 newtons. So here for this reaction, we assume the force is in directions. Force is in the direction of this bar, and we can assume either point out or point inward, up to you. So we follow up our textbook conventions and point out for FBC. So per the notation FBC. And the FBC, BC meaning the force in B and C, this bar. And also in this portion, let me change the pen's color here. So the force in bar AB and U, that should be in parallel in that direction. So that means in parallel directions. Okay. So you may assume the force is pointing rightwards. Follow up our textbook conventions, or you might assume the force is pointing leftward. Either way will be fine, and but keep all of your calculation consistent. So let us to follow up our textbook. So say here, let me assume that is FAB. Okay. So in terms of the loading here, we can convert further, even simplify, have a concise drawing just like this. About pin here, we have a given loading 30. We assume the reaction here, we assume reaction here. Now we have two unknowns, this one and this one. So to solve the two unknowns, we must have two equations, and which is from equilibrium equations. So the equilibrium force, the total force in x directions, assuming the horizontal direction is x, vertical direction is y. Okay, this one will be equal to 0. So that means from these equations, we have FAB. So here we might give us sign convention positive, pointing rightward. Okay, so in this way, per our assumptions, FAB is positive. Okay, and then FBC, it has the component, and horizontal component is that big. So follow up this kind of component here. So this portion will be equal to 4 over 5 FBC. Okay, so if you're using this triangle here, so basically, and that pointing leftward per sign convention is negative 4 over 5 FBC. Okay, and then the given loading has no component in x direction, so that is equal to 0. So the two force components are the only two in this system that is in x directions. And furthermore, we formulate the force in the y direction equal to 0. Okay, so for this case, again, we define our sign conventions positive, for example, upward. Okay, now we look at here, that's a given loading 30 and downward, so per our sign convention, that's negative. And for this FAB, it has no component in vertical directions, so 0. And for FBC, it has component pointing upward, and that component, again, looking at this triangle, that is 3/5 and FBC in magnitude. And again, this magnitude point upward, so per our sign convention is positive. So FBC equal to 0. So here we have equation 1, we have equation 2. Two equations allow us to solve for the two unknowns. Okay, we back to our issues here. So if some people like to assume your AB in pointing leftward, so accordingly, your FAB here, you need to change the sign. Accordingly, here don't have the exchange, don't nothing affect here. So once you change your sign according to your sign convention, you just proceed the calculations. Okay, don't worry. So now we're back to our original sign convention here to try to solve for equation 1 and 2. So in this way, we'll be able to find the magnitude. Determine the magnitude is 50 FBC. Okay, so basically here we solve for is 50. And right now, let's give up the unit for a moment. Okay, we will come back to there. And again, solve for the two equations, we can find the magnitude of FBC is 50 here, and FAB equal FAB, and FAB equal to 40. Okay. So I think I need to change my, yeah, okay. So basically in magnitude, we have this. So in this way, we know in this way, say if you plot, make any free bar diagram, for example, if you select cross section here. So if you would choose these cross sections, okay, if you would choose this cross section, then choose this portion on this cross section, the force should be equal to 50 and pointing in that directions. If you would choose this as your free bar diagrams, then the force equal to 50 in that directions. And to because that is action reactions, so basically they on the two opposite chosen cross section that must be opposite. So in a similar way, so say for example, if you choose these cross sections, and then if you pick these portions, okay, and then follow up, then the reaction force should be equal to 40 pointing to the rightwards. However, if you would choose these sections here, okay, and let me draw that one. If that is a section you choose, and so the force should be 40 in that sense. Good. Okay. Thank you.